a trigonometric function has inverse or not. A trigonometric function has inverse or not by taking the trigonometric function as it is. By taking the trigonometric function as it is. I'll start with an example. Like what? If you take sine function, in fact, its domain is set of real numbers and range is what? -1 to +1. -1 to +1. If it has inverse, no? If it has inverse, it must be like this. It must be like this. Sine inverse of -1 to +1, two set of real numbers. I repeat. If the sine function has inverse directly, then sine of its domain real numbers to its range closed -1 comma 1 closed, then it must be presented like this: sine inverse of -1 to 1 to r. Okay, but it does not imply that. Remember, very important point you have to understand. Very important point you have to understand. Why it does not imply? Taken as it is, sine function is not a bijection. Again, what is a bijection? Bijection is that bijection is equal to 1 1 plus onto. Bijection is that it is 1 1 plus onto function. What exactly I can say about 1 1 function is this. 1 to 1, or it is also said to be injection. 1 to 1 function means your classroom is the best example for that. Generally, every student in the class will have unique roll numbers. Correct or not? For example, if your class is consisting of 50 students, 50 students will have how many roll numbers?
50 rows.
50 roll numbers. What does it mean? Each one will have one roll number. One student will not have two roll numbers. No, never it happens like that. So, if you take the number of students as a set, for example, S1, S2, S3 and so on, S50 or the number of students, then their roll numbers has another set. This is student set A. This is student set B. And let me take their roll numbers as 1, 2, 3, so on, 50. Correct. Now your S1 will map to first roll number. Let me say, we are taking an example, that's it. Student 1 has roll number 1, student 2 has roll number 2, student 3 has roll number 3, and student 50 has roll number 50. Correct. This is a perfect bijection. But before that, what is a bijection? It is both 1 1 and onto. What is a 1 1 function?
Onto.
What is a 1 1 function? 1 to 1. Different elements in the set A must have different images in the set B. Okay, different elements in set A must have different images in set B. Obviously, it happens. It is a one-one function. And what is an onto function? No element of set B, no element of set B should be left without preimage. Without preimage. Are you with me what I am saying?
Yes, sir.
So is it an onto function or not? It is.
Yes,
It
sir.
is an
It's a
onto function.
bijection.
It is a bijection. So it is both one and onto. This must be very clear to you. This must be very clear to you. Okay. Now, if you don't want to see as a onto function, no. For example, a student from other section came to your class and he is sitting in your class. Are you with me what I am saying? A student from other section
Yes, sir.
came to your class and he is sitting in your class. He is sitting in your class. Let me say he is placed here. Let me say the student from other section placed here. Okay. Then you tell me whether he will have a roll number in your attendance register.
No, sir.
No, then it will not have the pre-event. Then it is not an onto function. Remember that. If any element does not have pre-image, then it is not a onto function.
Onto function.
Okay. Now you understand what is that?
Sir, is it 1-to-1?
Yeah, obviously one to one. One to one is in the name itself. We have that one student will have one roll number. One student will have one roll number. So yeah.
Okay, sir. But the other student has no roll number, no, sir.
Yeah, that's why I took the example. Beta. If you want to understand which
Yes,
is
sir.
not one function, I place the student there. Just to explain you what is not onto. Just to explain you what is
Yes,
not
sir.
onto. Okay. A better example, right? Better example we can take. According to Hindu Marriage Act, every male should have one and only one wife legally. Okay. Then, if you take all Hindu husbands as a set A and all women as set B, then if you map from Hindu husbands to women, then it is a one function. Of course, legally. Are you with me what I am saying?
Yes, sir.
So, like an example, yes, you will have better understanding if you take some lively examples like that. Don't see that as a violent concept. One function is a violent concept and onto function is a violent concept. It's not like that. It's not like that. It's very much that life examples can be we can take to understand these functions here. Okay. Now, in what way? This is related to inverse of the function. General definition is if f is mapping from A to B, we can immediately write f inverse maps B to A, f inverse map B to A if f is a bijection. You can write inverse only when it is a bijection. If it is not a bijection, you cannot write that. Remember that. If it is not a bijection, you cannot write that. So, I'll give you simple example now. Let us take a one function. Like you have x1, x2, x3, x4. You have y1, y2, y3, y4, y5. You have. So x1 to y2, x2 to y1, x3 to y4, x4 to y3. It is mapped like this. You tell me whether it's a one-one function or not.
Yes, sir. Function.
It's a one-one function. When it's a one-one function, okay, we took it directly as f maps A to B. Then you tell me whether f inverse maps from B to A exists or not.
Yes, sir. It exists because it's a bijection.
No, it's not a bijection. I said it is only one-one function, beta.
But
Right?
every element in B is having a pre-image in A, no, sir.
No, Wi-Fi do not have. It is like this.
Oh, there's Wi-Fi. Yes, sir. So it's not onto.
It's not onto. That's what you have to understand. Come on, tell me the reverse.
Yes,
Reverse
sir.
mapping now. Y1 to what? X2. Y2 to what?
X2,
X1.
Y2 to X1, Y3 to X4, and Y4 to 3.
What about Wi-Fi here? No mapping? It's not a function, please. It's not a function. That means f inverse does not exist for the function if it is only 1 but not onto. Are you with me?
Yes, sir.
But you must know the definition of a function. The definition of a function is that every element in the domain must have one and only one image in the codomain. One and only one image in the codomain. Okay. Now, let us take. Now, what is that I proved here? I took only one function. And for a one function, I proved that inverse directly does not exist if it is only one. Are you with me? What I'm saying? If it is only one function, inverse does not exist. Okay. Let me take now onto function. x1, x2, x3, x4, y1, y2 are there. You tell me, first of all, whether it is a function or not. It is a function because different elements in this domain will have unique image. That is, every element will have the definition of a function. F is said to be a function. F is said to be a function if to every element of set A exactly one and only one element is mapped. It is a function only. You tell me whether it's a bijector, whether it's an onto function or not. You have to see the codomain here for onto function. No element should be left without preimage.
Yes.
So is it an onto function? What, beta?
So it's onto, no, sir, because every element in B is having a pre-image.
Perfect. You tell me now. Let me write this now. I'm reversing it. Come on, you tell me the reversal. Y1, Y2, X1, X2, X3, X4. Tell me the reversal now.
Y1 will map to X1 and X3.
Yeah.
And Y2 will map to X2 and X4.
So is it a function? It is not a function because these elements have two images. which is against the rule of function. This element has two
It's
images.
not a function because x1 and x3 have the same image, have the same pre-image.
No, you have to see from domain here. In the domain, no element should have more than one image. No element should have more than one image. But y1 has how many images? Two images. Y2 has how many images?
Yes, sir.
Two images. That's the reason why it is not a function. Bhavya,
Function.
remember one thing. If you understand what is not a function, you will better understand what will be a function. What is not a function, you know? Any element of domain has no image, has no image, then it is not a function. Point number one. What is that? You repeat?
Any element of the domain has no image, then it's not a function.
Very good. And point number two, please. Point number two.
If any element of domain has more than one image,
it's not a function. It's not a function. So
function.
taken as it is. So two rules here. Not to be a function. Not to be a function. Two rules here. No element in the domain should be left without image. That is number one. Number two. No element should have more than one image.
One image.
Then it is not a function. Okay, it's not a function. So what is that you understand now? If it is only 1, 1, it will not have inverse. If it is only on 2 also, it will not have inverse. It will not have inverse. Then, to have inverse, what should happen? It should be both 1, 1 and on 2.
Both 1, 1 and on 2, which is a bijection.
That is nothing but this. You have to understand. In this case, what happens? Number of elements in set A is equal to number of elements in set B. Remember that. Number of elements in set A is equal to number of elements in set B. Then only
Set B.
inverse is also possible. Inverse is also possible only when both the elements are, both the number of elements in the two sets are equal. Okay. Now I hope you understand what exactly a bijection is. You tell me what is a bijection? If it is both 1, 1,
both 1 and on,
then it is a bijection. So in 1, 1 and on 2 function, the number of elements of set A must be equal to number of elements of set B. Okay? If it is like that, then inverse is possible for a function. Okay? Do you understand that or not? You tell me, please. Bhavya?
Yes, sir.
Are you there?
Yes, sir.
Okay. So now, let us discuss about the trigonometric functions. Now I explained this much, no? I explained this much about the bijection. Now you tell me whether sine function taken as it is a bijection or not. You tell me.
So what will set A and set B be?
Obviously, domain is a set A, and this is a range. I'll tell you. I'll ask you a simple question. Like you tell me now. You tell me now. What is sine 30 beta?
1 by 2.
1 by 2. What is sine 150?
1 by 2.
What is sine 390? What is 510 degrees? It is a sine function. One by two, you said. For 150 also
Yes,
1 by
sir.
2. For 390 also 1 by 2. For 510 also 1 by 2.
So here the
Whether it's a
domain
one.
has more than one image. So
Yeah.
it's not a function. So it has no inverse.
No. All the elements have the same image. It is not a one function. First of all, you tell me that. Whether it is a one function or not.
No, sir, it's not a
It's not a
one-one
one
function because
function.
they have the same.
Not one function. Understand that? Then what the
Yes, sir.
mathematician did, he observed, he tested its bijectivity. What I mean to say, when this function is behaving as a bijective function, he tested it. So, for that purpose, what he did, he took the values between minus 90 and plus 90. Okay, like you can take minus 60, you can take plus 60, you can take minus 45, you can take plus 45. Okay, you can take minus 30, you can take plus 30. You can take, of course, 0 also here. Degrees I'm talking about. Then he observed, what is that happening? For 90, when you take sine x, sine of minus 90 is mapping to what?
Minus 1.
Minus 1. Sine of minus 60.
Root 3 by 2.
Sine of minus 45.
Minus 1 by root 2.
Sine minus 30.
Minus 1 by 2.
This is sine of minus
Minus
1 by
1 by
minus 1 by root 2 minus 1 by 2. Sine 0. 0. Sine 30.
0.
Sine 30 beta. Sine
1
30. 1
plus
by
1
2. Sine 45.
plus 1 by
Sine
root 2
60.
plus
Sine
root 3 by 2
90. Now you tell me
plus 1.
whether it is a bijection or not. Whether it is a bijection or not. Are you there? Yeah.
It is
It is?
because the number of because it is 1 to 1 and it is on 2.
Yeah. So it is a bijection. So what the mathematician observed, sine function is behaving as a bijection when the value is lying between minus 90 and plus 90. Taken as it is its domain, it is not a bijection. That is why what the mathematician did, he restricted the domain here, then inverse defined. Very basic point in inverse trigonometric functions. Very basic point in inverse trigonometric functions is that the mathematician restricted the domain of the function like what? Sine of, he took it between minus pi by 2 to plus pi by 2 to minus 1. That is, this is restricted like this. If it is not restricted, inverse won't exist. Inverse won't exist. Then
Yes,
inverse
sir.
is defined. Come on, tell me now. Sine inverse of what? Minus 1 to
Minus 1 to 1 minus pi by 2 comma plus pi by 2.
So, what is that you have to understand? This is domain here, and this is range here. Are you there, Bhavya?
Yes, sir.
So, what is that you have to understand? Whenever, very, very important point, whenever you're talking about sine inverse of any value, sine inverse of any value, sine inverse of that value must lie between -1 plus 1, very important point, and the result must lie between -90 plus 90. What does it mean? If you write something like y is equal to sine inverse x, let me say, y is equal to sine inverse x is valid when x belongs to
When
what?
y is x belongs to -1 and 1, and y belongs to minus pi by 2.
Very important. Very important. Very important. Similarly, for cos and the remaining trigonometric ratios also define the basic point, then you will understand in a better way why the ranges. Otherwise, if it is directly inverse is existing for the trigonometric function by taking it as it is, what happens? These two will be reversed. Domain becomes the range and range becomes the domain. It is not happening so here. Only range is becoming domain, but the domain is not becoming range here. The reason is taken as it is not a bijection. Are you there, beta?
Yes, sir.
So, similar is the case with the remaining trigonometric inverse trigonometric functions like cos inverse x and tan inverse x and secant inverse x, cosecant inverse x, and cot inverse x. All these you can understand through the table.